Hello students, welcome back. In this opportunity, we'll talk about matching, which is an impact evaluation method using econometrics. Let's start. So we'll start with the motivation on why we should use matching, and then we're going to talk about the matching method, and then ways to find a match, and we're going to talk about the propensity score matching before we do the estimation. So let's start with the problem of counterfactual. It's always good to remember why we need the potential outcome framework in the discussion of impact evaluation. So for each individual I, there are two potential outcomes. The first one is the outcomes when the individual receives the treatment, and then the counterfactual, which is the outcome if the individual did not get a treatment. And so given the potential outcomes, the outcome for individual I is going to be the counterfactual plus the difference between the actual outcome and the counterfactual multiplied by an indicator of treatment D. And so the causal impact or the causal effect of a program is the difference between the outcome when the individual receives the treatment and its counterfactual. And we've seen this potential outcome framework several times already, and then the problem with estimating the causal effect is that we're never going to be able to identify the counterfactual, the outcome should the individual when the individual do not take the treatment. And so the fundamental problem of evaluation is no counterfactual. So for example, for individual who receives the treatment, then we're not going to be able to observe the counterfactual when the individual did not get the treatment. And similarly, for individual assigned to the control group, we're never going to be able to understand the counterfactual should the individual receives the treatment. Okay. Knowing the counterfactual is going to be important because if we know the counterfactual, we're going to be able to calculate the average treatment effect, which is the expected difference between the outcome receiving the treatment and its counterfactual, or it's the probability of individual receiving a treatment multiplied by the average treatment on the treated, and then the plus the probability not receiving the treatment multiplied by the average treatment not the treated. Okay, so the methods that we've studied so far seek to construct a valid comparison group, and matching is just going to be another method to do just that. So matching is another method that applies statistical techniques to construct a comparison group. Now the idea is that matching identifies average unobserved counterfactuals. Okay, so let's go over the idea of matching methods. So when we talk about the matching methods, we need to talk about the assumptions, the underlying assumptions. So the first underlying assumption is that selection on observable. And so conditional on observable X, then the assignment to treatment D or the getting the treatment or not is going to be independent of the potential outcomes. So again, conditional on observables, then getting a treatment is going to be independent to the potential outcomes. So if we know these observables, then getting the treatment is somehow going to be independent of the potential outcomes. Now, this is equivalent to the probability of receiving the treatment conditional on the potential outcomes and the observable is just going to be the probability of receiving the outcome conditional on observable X. And the expected or the average of receiving a treatment D equals to 1 conditional on the potential outcomes and the observable X is going to be the average probability of receiving the treatment conditional on the observable X. And so the differences between the treatment and the comparison group are going to be captured in X. And so the average treatment on the treated is going to be the following. Since conditional on X, the potential outcome or the counterfactual is independent of getting on the treatment. And so we can use the average outcome of individuals who do not receive the treatment as the counterfactual of the counterfactual for individuals who receive the treatment. And similarly, since conditional on X, getting the treatment is going to be independent or independent of the outcome when receiving the treatment, then we can use the expected outcome of individuals who receive the treatment as the counterfactual for the control group. Okay, and so in this particular case, the average treatment effects is going to be conditional on X, then the outcomes are going to be independent of getting the treatment or the treatment. Now, what will be the threat to identification? The main threat to the identification is that when the assignment is not only affected, assignment to the treatment is not only affected by the observable X, but also on the unobservable. And so this is going to be the key identification method, the selection on observable. And the threat will be that the selection could be unobservable and also the unobservable. Now, if it's the unobservable, then this is something that is quite unfortunate because we cannot see the unobservable. Okay. So again, just like in the standard OLS framework, differences between the treatment and the comparison group are not going to be captured in X. And so differences between the two groups are on the unobservable characteristics. Now, we observe individuals in the treatment and the non-treatment unit with the same characteristics. So this is going to be the second assumption of common support. So basically, the average treatment on the treatment is going to be that the probability of individual receiving a treatment is going to be less than 1. And average treatment not treated is going to be that the probability of receiving the treatment is going to be larger than 0. And so basically for the average treatment effect, it's going to be between 0 and 1. Okay? So imagine a particular scenario. Suppose that when X is equal to a particular value X, then the probability of receiving the treatment for that X is going to be 1. Now, the issue is that for X equal to little x, then everyone gets the treatment. Now, in that particular case, we won't be able to find individuals to be matched, individuals in the control group or individuals who do not receive the treatment to be matched with individuals who receive the treatment. Okay, so this is the particular issue when for a particular value x, we won't see individual in the control group. Okay, and so in this particular case, we won't be able to obtain a valid comparison group. And similarly, now suppose that for a particular value of x, then the probability of receiving a treatment is going to be 0. Now, in that particular case, we won't find individuals who actually receive the treatment. And so we won't be able to match individuals who do not receive the treatment with those who receive the treatment. So in that particular case, we won't be able to obtain a valid comparison group. So having a common support is actually going to be key in the matching methods. The idea is that we will be able to find individuals that receive the treatment and those who do not receive the treatment at the same time. So given the two assumptions, selection on observables and common support, if these assumptions hold, then we can use the observed average outcome of the non-treatment units to estimate the counterfactual outcome. Now let's talk about ways to find a match. So the goal of matching is to approximate the characteristics that explain individuals' decision to enroll. And this procedure requires a very large data set. Now, let's take a look at this particular example to provide you an idea on why we're going to need a large data set. So suppose you have two groups. Under the left columns are going to be the treated group, and on the right columns are going to be the untreated group. Now, suppose that the variables that determine whether or not individual receives a treatment is going to be the number of months unemployed and an indicator of poor. Okay, so that's going to be our observable. So the selection on the treatment is going to be based on the two variables. So for individuals who's been unemployed for 2 months and is actually poor, we can actually identify the match. Okay. And similarly, for someone with who's been unemployed for 6 months and then is poor, we can actually find the match. And as well as for individuals who've been unemployed for 8 months and is also poor. Now, it's quite difficult to identify a match for each of the units in the treatment group. Okay, so if we go back to the previous slide, we won't be able to find a match for individual who's been unemployed for 5 months and it's poor, and we weren't able to find a match for individual who's been unemployed for 10 months and it's also but the individual is not poor. And so the issue here is that we won't be able to find a match for each unit in the treatment group. Now, another issue is that the observable that we use for matching was based on the number of months unemployed and poverty status. However, imagine if the list of observed characteristics is large, and imagine that each characteristic takes on many values. So for example, whether or not an individual receives the treatment is going to be determined, or the selection is going to be based on expenditure. Expenditure is going to have continuous value, and so finding a match is going to be very, very difficult. Okay, so the idea is that we're going to run into a problem called the curse of dimensionality. And so the dilemma is that if we limit the set of observed characteristics, then the matching is going to be affected by unobservable. So it's going to violate the first assumption. However, if you increase the number of characteristics, the issue is that it's going to be quite difficult to find a match. And so if you increase the number of observed characteristics, you may be dealing with an issue in fulfilling the common support assumption. So there is always this trade-off between the selection on observable and the issue of common support, or the assumption of the common support. So that's something that we need to keep in mind when we're using a matching method for impact evaluation. And so, given the issue of the curse of dimensionality, the literature moves forward with the idea of why don't we create a propensity score, and so instead of just matching individuals based on some factor of observed variable, why don't we match individuals on the propensity score? So a solution to the curse of dimensionality problem is going to be the propensity score matching. So the method computes the probability that the unit is enrolled in the program using observable characteristics. Now we do this for treatment and non-treatment units. And so we are going to compute the propensity score for the treatment, and we're also going to compute the propensity score for the non-treatment units. Now, it's very important that we only use the baseline or the pre-treatment observable characteristics to calculate the propensity score. And the propensity score is always going to be between 0 and 1. Okay, so suppose that I'm going to denote the propensity score as E. Then the propensity score of x, E of x, is going to be the probability that an individual receives the treatment for a particular value of the observable x. Now, the score is going to be used to make this particular assumption, and so conditional on the propensity score E of x, then getting the treatment is going to be independent of the observable x. And so if we combine, then conditional on x and the propensity score E of x between 0 and 1, then the treatment, getting the treatment D is going to be independent, or is going to be independent on the potential outcome. And so given the assumption that conditional on E of x, getting the treatment is going to be independent of x, then we could get that conditional on the propensity score E of x, then getting the treatment is going to be independent of the potential outcomes. And so what we're going to do is we're going to match treatment and non-treatment units with the closest propensity score. The matched non-treatment units is going to become the comparison group. And the average difference in outcomes between the treatment and the match comparison is the estimate of the impact. So the propensity score matching mimics a randomized experiment. So the treatment and comparison units are similar in the sense that they have the same propensities to receive a treatment. The difference is that one receives the treatment and the other does not receive the treatment. Okay, so let's talk about the steps to get to PSM. So we're going to find representative surveys to identify the treatment and non-treatment units. We're going to pull the sample and estimate the probability that each individual receives the treatment based on observable characteristic. And it's important to include relevant variables to avoid a bias estimate. And so we can find relevant variables in the theory as well as previous empirical findings, and we can always do formal statistical tests when we estimate the propensity score. Always remember the trade-off. If you have a smaller set of characteristics, then you may be facing an issue of not fulfilling the selection on observable assumption. However, if you have a large set of characteristics, then you may be facing the issues of problems of common support, because it's going to be difficult for you to find a set of individuals who receive the treatment and those who do not receive the treatment with the same propensity score. So always remember this trade-off, although this trade-off is going to be significantly reduced in the propensity score matching framework, but it's still an issue to pay attention to. Okay, so after we estimate the model to obtain the propensity score, we're going to use the estimated model to obtain the propensity scores, and we're going to restrict the sample to units with a common support. For each enrolled unit, we're going to locate a subgroup of non-treated units with similar propensity scores, and we're going to test whether the means for the treatment and non-treated units are statistically different. So the measure of the impact is the difference between the outcomes and the treatment and the match of the treatment and the match comparison. Okay, so let's start with the estimation strategy. So the matching strategy is the following. We're going to pair each treatment unit I with one or more comparable non-treated units. And we're going to associate outcomes Y, observe a matched outcome, and Y I hat 0 given the weighted outcome of its neighbor. And so basically we're going to construct the counterfactual for individual in the treatment group given this following weighted average. And so the estimated counterfactual is going to be the weighted average between the observable. So let's talk about the notations that we have. So C of I is the set of neighbors who do not receive the treatment, and this is the neighbors of the individuals who receive the treatment, subject I. Okay, and then Yij is going to be the weight of non-treated j, and the sum of the weights must be equal to 1. Okay, so I'm going to create a simple illustration on this strategy. So suppose that this is the line for individual who receive the treatment, and this is going to be the line for individual who do not receive the treatment. So let's write this is G equals to 1. So basically these are individuals who receive the treatment, and these are actually individuals who do not receive the treatment. Okay, and suppose that for individual who receive the treatment, this is going to be the observation. So we have, this is the main observation. And so what we're going to do is we're going to say can we find individuals with the same propensity score similar to individual. And so what we're going to do is we're going to find individuals with a propensity score close to the one who received the treatment. So suppose that we have the individual here, and then we also have the individual here, and we also have the individual here. So basically we have 4 observations of individuals who do not receive the treatment for the individual who received the treatment. And so basically we have actually more than a pairing. We have 4 individuals who do not receive the treatment with propensity score very close to the treatment group. And so what we're going to do is that given the 4 observations of outcomes of the control group, we're going to create an average counterfactual. Okay, and so we have 4 outcomes, and so we're going to take a weighted average. Now the question is, what is the weight? Now the weight is going to be determined by the matching method that we can choose from. And for example, we can use the simplest model available. So for example, we can use the fact that the weight is similar for each observation. And so given that there are 4 observations, then the weight for each observation is going to be a quarter. But we can also discuss this situation where the closer you are to the observation of the treatment group, then the weight is going to be higher. That's also another possibility of weighting. Now the idea is that the weight has to be equal to 1. Okay, so now again, going back to the average treatment of the treated, then the estimated ATT is going to be the difference in the outcomes and its counterfactual conditional for individual who receive the treatment. Now we can actually estimate the ATT using the average counterfactual estimated from the control group, which is the y hat 0. And so basically the estimated ATT is going to be the average difference between the observed outcome for individual who received the treatment and its estimated counterfactual. And so basically what you need to do is you need to calculate the difference for each individual in the treatment with the counterfactual, the estimated counterfactual y0 hat, and then take the average of the difference and you get the ATT. Okay, and NT is going to be the number of match treated in the sample. So again, since we have the assumption of common support, then individuals who are not matched is not going to be included in the estimation of ATT. Okay. So we've talked about the idea on how to get a match for individual in the treatment group conditional on the propensity score matching EX. And so again, going back to the matching strategy, one-to-one matching is still the most desirable. However, it's quite difficult to observe 2 units with the same propensity score because the propensity score is basically a continuous variable, so the probability of getting a one-to-one matching is very, very low, if not 0. And so the matching methods have been developed to deal with this problem. And so the first thing is to find nearest neighbor matching, or we can do radius matching. In this particular case, we're going to set a particular radius and observations of individuals who do not receive the treatment within the radius is going to be matched. We can also do a kernel matching, or we can do stratification matching. So these are several ways to do the matching. Let's start with the nearest neighbor matching. So basically, this is the absolute difference between the estimated propensity scores of the treatment and the control groups are minimized. So the group of control individuals are selected such that C of PI is going to be the minimum between the propensity of the treatment I, PI, and the propensity for the control group PJ. Okay, and so this is going to be the idea of nearest neighbor matching. Now, the radius matching is for when each individual in the treatment group is matched with individuals in the control group whose scores are within a predetermined interval of the treatment individual's propensity score. While as in the kernel matching, each individual in the treatment group is matched with the weighted average of the control individual's outcomes. Now, the way that we weight the observations of control individual outcomes are going to be different. So you can use uniform in the sense that each observation is going to receive the same weight, or you can always use, you can also use the triangle, in which the weight is higher if you are closer to the propensity score of the treatment group, or you can also use kind of like a Gaussian in the sense that the closer that you get to the propensity score of the treatment individual I, the weight is going to get higher, but it's going to get higher at a smaller pace. Okay, so the syntax that we're going to use in Stata is going to be referred to as the PSCORE. So PSCORE is going to calculate the propensity score. So PSCORE also tests the balancing hypothesis through this algorithm. And so basically, the P-score is going to split the sample in k equally spaced intervals of E of x, and then within each interval, test that the average E of x of treated and untreated do not differ. And if the test fails, then split the interval and test again. And continue until in all intervals, the average E of x of treated and untreated units do not differ. And within each interval, test that the means of each characteristics do not differ between the treated and untreated. And we're going to use data package PSMatch2 and PSTest for estimation and balance check. So we'll take a look at this data for the estimation or sample exercise using the propensity score matching. Thank you, and I'll see you in the next opportunity.